Hi, today we are going to talk about experimental probability. Experimental probability is different from theoretical probability. Theoretical probability is just what do we think is going to happen? Experimental probability is what actually happened. Okay, so theoretical would be looking at this jar and saying, I expect or I predict that I'm going to draw a lot of brown marbles out of this jar because I see a lot of brown ones. That's just my theory. That's my expectation. But in reality, it certainly could possibly happen that I draw no brown ones. So we're going to go ahead and take a look at this problem, and I'll show you experimental probability. I took 12 marbles out of this jar. 4 were brown, 5 were light blue, 2 were gray, and the rest were dark blue. What is the experimental probability of drawing each color? So, experimental probability is very similar to theoretical probability. It's just the numbers are different. So, the total number of times I drew a marble out of the jar goes to the bottom. So the total number of experiments I did, right? Taking a marble out of the jar would be one experiment or one event. Okay, one thing happened, I drew it out of the jar. Okay, and I did it 12 times. Now I should mention that what's happening here is I'm taking a marble out of the jar and putting it back in. So it could potentially get drawn again. So there are a total of 12 times that I drew marbles out of the jar. 4 were brown. Well, that means the top is 4 because the part in our experiment that were brown was 4. Now, looking at this picture, we sure thought that there were a lot of brown, but I only got 4 of them, which means if I simplify that, I only got brown 1/3 of the time, or 0.3 repeating, or 33% of the time. So my experiment showed me that about 1/3 of the time I've been drawing them. Whether there's actually 1/3 of the marbles are brown, that we don't know from the experiment. All we know is that we drew 1/3 of the time brown. Okay, 5 were light blue. 5 out of 12. Now that doesn't simplify to anything else, but we can change it into a decimal. 5 over 12 is 0.416 repeating. Whew. Which we can put into a percent, 41.6 repeating percent. So it's approximately 42%. Now, if we look at this picture, there's way less light blue marbles than there are brown marbles. So we would have thought, theoretically, that we'd get light blue less often than we got brown. But as chance happens, right, we ended up drawing more light blue marbles than we did brown. So in our experiment, about 42% of the time, we got light blue. Does that mean 42% of the marbles are light blue? No, that's not what it means. It just means that in this experiment, we happened to get a bunch of light blue. Okay, 2 were gray. So that's just 2 out of 12. So that simplifies to 1/6, which is something. Hey, 1/6. Whew, man, I got a lot of repeating decimals. 0.16 repeating. So 16.6%, which is approximately 17%. So approximately 17% of the time, I got, what was that? Gray. And it says the rest were dark blue. So I just have to figure out how many were dark blue. Well, there were a total of 12 trials. So I'm literally just going to do 12 minus 4 minus 5 minus 2. Oh, well, there was only one left. So one of them was dark blue. And again, I could put that, I can't simplify that fraction, but I could put it into a decimal. I could put it into a percent. And then that would tell me the percent of the time that I got in my experiment dark blue. Again, doesn't mean that 1/12 of the marbles are dark blue. It just means that's what I got in my experiment. So that is experimental probability. Again, the difference between experimental and theoretical is that theoretical is what we think is going to happen. Experimental is what did actually happen. Thanks, bye.